The rise of quantum computing has everyone excited about the possibilities that lay ahead, and it's not hard to see why. Quantum computers can help us make better drugs, crack some of the world's most complicated encryption algorithms, and maybe even simulate other universes. But while these are all very cool, they all happen offline. But what if we had a way to combine the strangeness of quantum mechanics with our existing internet infrastructure? What if we could have a quantum internet? Welcome to my channel. Today we are answering: is the quantum internet our new digital frontier? There are two main reasons that people want to develop a quantum internet. The first reason is quantum communication, which includes both encryption and distribution of quantum information. The second reason is quantum computing. Let's start with communication. Most of the data we send over the internet today is encrypted because the alternative is to send everything in plain text. It's not exactly secure. Now, this means that when you use the internet to book a flight or purchase something online, your information like your credit card number and name isn't just floating around out there. But the methods of encryption we currently use are still vulnerable to attack, especially as quantum computers get bigger. You see, many of the encryption algorithms we currently rely upon are based on mathematical problems that are easy to generate but difficult to solve. Breaking these encryption algorithms on a regular computer is like trying to find the best route through traffic without a GPS. It's doable, but it takes a long time. It's called a brute force attack. However, on a quantum computer, the problem becomes easier, like having Google Maps for your car ride. That's why the National Security Agency says that with a sufficiently large quantum computer, many encryption algorithms that we use will become obsolete. Now, one solution is to come up with new encryption algorithms that are also safe from quantum attacks. But another solution is to leverage the properties of quantum mechanics to create an encryption algorithm so secure that only the intended recipient can actually read the message. This is often referred to as quantum key distribution, or Q key. The idea is that you and your friend Bob want to share a secret key. This key is the password to your encrypted communication. Now, typically with normal encryption, Alice would just send the key to Bob. But this is not ideal, since the entire point is for the key to be secret. So instead, Alice and Bob each create their own random key. They then perform a series of operations on their keys and compare the results. If they end up with the same result, then that's their secret key. But here's where quantum mechanics comes into play. Every time they compare keys, Alice and Bob exchange photons, the particles of light that represent either a 0 or a 1. And instead of sending these photons in a regular computer, they send them through optical fibers, which maintain the fragile quantum properties of the photons. These photons go through a device called a beam splitter, which randomly routes each photon into one of two paths. Then the photons arrive at Bob's end, where he also has a beam splitter. Now remember, these beam splitters are random, so we don't know which path any given photon will take. But we do know that a photon coming in on one side will always come out on the other side on a different path. Using this property of quantum mechanics, Alice and Bob compare notes on the paths that they chose. If they used the same path, they know to keep that bit a 0. If they used different paths, they know to keep that bit a 1. They repeat this process until they have generated a key. Now, because of the properties of quantum mechanics, if someone tries to eavesdrop, they will disturb the photons and Alice and Bob will notice. So this kind of encryption is perfectly secure. But it's not just about encryption. Another important quantum communication technique is quantum teleportation. You may have heard that Einstein said that it's impossible to teleport matter. And he was right. However, we can teleport quantum information. Now, this isn't quite Star Trek-style teleportation, but it does mean that we could one day send messages instantaneously across the globe. Here's how it works. Say that Alice wants to send a message to Bob. She takes her message and encodes it onto a qubit, which is the quantum version of a bit. She then needs to send that qubit to Bob. She can't do this directly, so instead she sends a qubit to a satellite and then tells Bob which direction the qubit is pointing. Bob then takes his own qubit, which is in a special configuration, and performs a series of operations on it depending on the information that he received from Alice. This ends up leaving him with the same information as Alice, but now on his end. Because the message was sent to a satellite, this effectively teleports the message instantly no matter how far away Bob is. This could be useful for tasks requiring real-time control, like operating robots or satellites from Earth. Quantum teleportation might sound familiar. You might be thinking, hey, didn't they already solve this in Star Trek? Well, the answer is yes and no. You see, quantum teleportation is similar to the transporter in that both techniques move the state of an object from one location to another. But unlike the transporter, the original object is destroyed in the process. So, maybe not quite sci-fi yet, but what about quantum computing? This is where the quantum internet starts to look more like science fiction. The basic idea is that instead of relying on local quantum computers, we can set up a network of quantum computers that are linked together. This raises a few interesting questions. For example, how do you share data between quantum computers? Or how do you run a program on multiple quantum computers? But assuming we can figure these things out, researchers are optimistic that we can scale up quantum computers much faster if we have a quantum internet. One study found that linking up quantum computers in a network would allow us to create much larger systems much faster than if we tried to increase the number of qubits on a single computer. Researchers believe that this is because once you have enough qubits, adding more won't increase the power of the computer, but rather the ability to communicate between them will. In other words, the network structure will become the bottleneck, not the individual computers. One major challenge to developing a quantum internet is maintaining coherence. Remember those fragile photons we were talking about earlier? Well, it turns out that qubits are pretty fragile too. They are easily disturbed by temperature fluctuations, noise, and other environmental factors. This is called decoherence, and it makes it very difficult to transmit quantum information. One way we can overcome this is by placing the qubits in a controlled environment like supercooled liquid. But another option is to move the qubits closer together. Several research groups are experimenting with putting qubits on chips so that they can be packed closer together. Not only will this make it easier to transmit quantum information, but it will also make it easier to connect them to regular computers. So this is great news for the quantum internet. But even though researchers have made a lot of progress in creating qubits that can be mass-produced, we are still a ways away from having them on consumer electronics like our phones or computers. The goal of the quantum internet is to move quantum computers from something that you hear about in the news to something that you can actually use every day. And there's a lot of work that goes into making that possible. But as our technology continues to advance, we may see quantum computers and the quantum internet go from science fiction to science reality. So what do you think? Does the quantum internet excite you? Let me know in the comments below. And don't forget to subscribe for more fun science videos. Speaking of fun science videos, did you know that we have a whole series of videos on Brilliant that teach you everything you need to know about quantum mechanics? I learned a ton, and it really helped me understand topics that otherwise seem very confusing. I particularly liked the Quantum Objects Interactive module where you can learn about superposition and entanglement by actually manipulating the qubits yourself. And they have lots of other courses on topics like AI and logic too. The great thing about Brilliant is that their courses are interactive and visually stimulating. Instead of watching a lecture video, you learn by doing, which is an extremely effective method for learning new things. And if you're already learning something, it's easy to keep going. Brilliant has carefully designed their courses so that you feel like you are making steady progress. And that feeling is extremely motivating. Thanks for watching and learning with us.